Alright, so I think we have 2 more videos left. So we have, we'll go through 8 through about 11 or so, and then we'll do the last bit, like domain and range stuff at the very end of the last video. Alright, so for number 8, we have Barry. He is buying CDs online for $8.99 each, plus $3 for shipping. If he buys CDs at Music Mart, they cost $9.49 each, but there is no cost for shipping. Solve the equation below to determine C, the number of CDs Barry buys online at Music Mart while shopping for the same amount of money, while spending the same amount of money. Show your work for full credit. Okay, so we set something up like this. We want to set up 2 different expressions. So if he just buys it online, we're going to be using this information. If he buys it at Music Mart, it's going to cost him this much, and then there's not going to be any shipping charge. We're going to be using that bit of information. Alright, the important thing here is it says that he wants to be spending the same amount of money. Okay, so we're going to use this and that, and if he wants to spend the same amount of money, all that means is we're going to set those 2 equations equal to each other. So again, showing our work in here, we're going to have $8.99 and then that each part right here tells me that that's where the x is going to go. So x plus 3 equal to, and on this side we have $9.49 each once again. So equal to, and then we're going to have $9.49 each, or $9.49x. We're going to go and draw our line down our equal sign. And now we're going to go ahead and solve. We want to get the x completely by itself. Now, the thing is that I have an x here, I have a number here, and I have an x here, right? Or in other words, I have a variable, number, variable. Since I have 2 variables, one on each side, I then go to my numbers. I only have one number, and that number is here, right? So what I can do is I can actually label this side numbers, which means that this side is going to be variables. And the reason that I want to label this side numbers is because I only have one number, and so if I don't have to move that number back and forth, it's going to make it a lot easier. So I'm going to go ahead and cover up the 3. I want to get rid of that 8.99x, so I'm going to subtract 8.99x. $8.99x minus 8.99x is going to reduce to 0. This is going to come down. Now we have 3 is equal to, if we add this in our calculator, 949 minus 899, that's going to give me 50, or 0.50x. Right, in other words, like 50 cents x. My last step to get the x completely by itself is going to be to divide by 0.50. And then we get that x is equal to 6. Or C, I guess, is the variable that they wanted us to use. X is equal to 6. That means that he can buy 6 CDs, and he spends the same amount of money if he buys 6 CDs in both places. Alright, so that was 6. Going on to that was number 8. Going on to number 9, we're going to function notation. Now let me show you guys how we set up function notation. So it says if f of x equals 2x plus 9, what is f of negative 3? Justify your answer for full credit. So you would draw your table. This is the way that I teach it. Maybe your teachers taught it a little bit differently, but the way that I teach it is we draw our table, we write x on one side and not y on the other, but f of x. Remember that f of x and y, they're the same thing. In fact, I always say that f of x is just a fancy y. Now, our value, so this is our original equation, original function. This is the value where this is the extra bit of information that they give us. Okay? Now, based on this, depending on how it's written or how it's given to us, I'm either going to put my value here or I'm going to put my value here. Now, I'm going to go ahead and tell you guys how you know where to put it. So if your value is on the inside, it's going to go in your x. If it's on the outside, it's going to go on your f of x or your y side. Now, inside or outside of what? Inside or outside of the parentheses. So when we look at the parentheses, there they are. I'm going to make them a little bit bigger. There's my parentheses. Do we see how that negative 3 is on the inside of the parentheses? Right? It's on in between those two. So I'm actually going to put my negative 3 in here. Okay? Now just to kind of give you guys an example of what it would look like outside, that would be something like f of x equals, I don't know, 12. Right? If it was set up something like this, you see how the parentheses are here. Your number is on the outside way over there. If that was the case, then 12 would go over here. Right? We're not working that problem, so don't worry about this 12. But if we were working a problem like that, that's what we would do. Okay? We put the number on the inside. Basically what this tells us, we want to find the number that goes with this negative 3, so we need to find the y value that goes with this. Alright, so that's what we're trying to do. We're trying to find this. Now here's what we do whenever we're given our x. Whenever we're given our x, all we're going to do is we're going to take that negative 3, we're going to replace the x with negative 3 anywhere where we see x. Okay, so anywhere where there's an x in my original equation, I'm going to replace it with the negative 3. So we go back into our equation, I see an x there on the inside and I see an x there. I'm going to replace both of those with the negative 3. This is going to become f of negative 3 equal to 2 parentheses negative 3 plus 9. Remember that in algebra, whenever you plug in a number into an x, if it's not already in parentheses, put it in parentheses. So this x, I'm going to replace it with parentheses negative 3. I'm going to draw my line down my equal sign. This side right here, for whatever reason, always throws student off. They're like, what? F of negative 3? What does that mean? You're actually not going to do anything with that. That's going to go all the way down to the bottom. This is going to be f of negative 3 equal to. On this side, all we do is just type this into our calculator and simplify, which I think I've already done it. I've already typed it in. It's going to be 2 parentheses negative 3 plus 9. If I hit enter, I get 3. Right, so my answer is just going to be f of negative 3 equals 3. So this whole thing is my answer. Make sure that you guys write the whole thing on your test. Not just 3, not just, whatever. Write the whole thing. So your answer to this would be f of negative 3 equals 3. Again, all that means is now I've gone in and I've found my y value. My y value is 3. Again, all function notation tells you is, hey, if you plug in an x where all of your x's are, your y value is going to be 3. That's all that tells you. And that's why we write it in function notation. We just plugged in a 3 and we got 3. That's all function notation tells me. So this would be my final answer. Let's look at number 10. Number 10 should be set up pretty much the exact same way. And let's go ahead and see how this one would turn out. So again, we have our original equation, wx equals negative 3x minus 6. Our question is, or our extra bit of information is, what is w of negative 4? Justify your answer for full credit. So we would draw our table again, x and f of x. Remember, this is on the inside. This is on the outside. Right, inside, outside. So if I look at my information here, that negative 4 is on the inside of the parentheses. So once again, we have a number in there. We're trying to figure out what our y value is. Again, all this means, the reason that I do this table is, hey, that tells me that I'm going to replace all of my x's with negative 4's. Right, if I had a number over here, if I had, let's say, 12, that would tell me, hey, I'm going to replace all of my f of x's with 12. Right, we don't have that, so we don't have to worry about it this time, but I replace all my x's with 4's, negative 4's. So I take this x here, and I take that x there, and I'm going to replace both of those with a negative 4. So we have w of negative 4 equal to negative 3 parentheses negative 4 minus 6. Okay, again, if there's not a parentheses already around it, like for example this x here, when we plug it in, we want to make sure that we put parentheses around it and then plug in the negative 4. We draw our line, we're going to solve. Remember the w of negative 4, this side right here, whatever your function notation is, this just goes all the way down to our final answer. And our final answer, once again, this should be, as soon as you set it up, once you set it up, it should be pretty easy. Because all I do is just type this into my calculator. set it up this way, not second graph, what am I doing? Hit enter, and we get 6. So, and make sure that that's a minus sign, right? Because we read this equation here as -3 times -4, or parentheses -4 minus 6. Make sure that that third subtraction sign is a minus 6. So we get 6. So our answer is, once again, just simply going to be this. W of -4 equals 6. So again, all that tells me is, hey, whenever you plug in a -4, the y value that you get that's associated with it is going to be 6. Again, we can take that out and say, hey, our answer is 6 on that side. All right, we'll fit in number 11, and then we'll do domain and range on the other side. All right, number 11. Once again, we have parentheses, so we're going to go ahead and distribute. In fact, I'm going to go ahead and work this out on a separate sheet of paper and then come back to number 11 just because I feel like I'm going to need a little bit more space to work this. So we have 5 parentheses 6 plus 3r plus 7 greater than or equal to 127. We're going to draw our line down our equal sign. First step is going to be to distribute, so we have 5 times 6, which is going to give me 30. 5 times 3r, which is going to give me 15. R. 7 is going to come down. 127 is going to come down. And then we're going to keep our inequality. Remember that once you distribute the 5 goes away. All right, so now our next step is to combine like terms. We have 3 different terms over here. We have the 30, the plus 15r, and the plus 7. Right, we have 3 different terms. Of those terms, the 30 and the 7 are the same type of term. They're both numbers. So we can actually put those 2 together. Again, all that means is just add them together. 30 plus 7 is going to give me 37. 15r, that's one thing that we couldn't combine it with anything else, so we're just going to bring that down. And then over here we have the 127. Again, we never touched that, so it's just going to keep coming down. So far we haven't done anything with that 137. It's just been following down, but that's okay. Now we get to this step right here. We have one variable, that's the 15r. Then we have a number. So since our variable is on this side, on the left side, we're going to go ahead and label this variables. Label this then numbers. Since our variables are on this side, that means variables can stay. I can go ahead and keep that variable here. I need to get rid of the number. I need to put the numbers on this side. So I need to get rid of this plus 37. The way that I do that is minus 37. So we're going to subtract 37 from both sides. This is going to create a 0 pair. 127 minus 37 is going to give me 90. Greater than or equal to 15r is going to come down. And again, just make sure that you keep extending your line if you need to, if you need more space. Now we get to 15r greater than or equal to 90. I divide everything by 15. And I get that r is greater than or equal to, it's going to be 1, 2, 6. Is that right? Yes, 6. So we have r is bigger than, greater than, or equal to 6. So this is going to be my final answer. Alright, so I'm going to go back to our problem. I'm going to go ahead and write that answer down. So we're going to say, and obviously on your test you want to show all the work. But I'm just going to go ahead and write that r is greater than or equal to 6. I'm going to go ahead and graph it. So all I'm going to do is just draw a little dash here. I'm going to label this side as 6. Obviously this next one would be 7. Right, the one before it would be 5. Right, we've all seen a number line before. Alright, next I look at my inequality. Remember that less than and greater than, those give you open circles. Less than or equal to and greater than or equal to give you closed circles. Or shaded in circles. So since we have greater than or equal to, we're going to have to use a closed circle. So at the 6, I'm going to go ahead and put a closed circle. And then you just look at where it points. So if I made this into an arrow, right, if I made this sign right here into an arrow, that arrow would point that direction. So I'm going to go ahead and extend my line, or extend this, or shade it in some way, extend it this way. All of the values on this side, and continuing obviously forever this way, all of the numbers that are on this side are going to make this statement true. R can be any number bigger than 6. So then on the bottom it says, list 3 possible solutions to the above inequality. So what that means is, and you want to think about it, 7, would 7 work if I plugged it in for R? In other words, is 7 greater than or equal to 6? The answer is yes, right? That would be true. So I can list really any number bigger than 6 would work, right? 7, if we keep going, we would have 8, 9, right? And if we kept going to infinity, we would have 1,000, a million, a billion, right? Somewhere in here we would have 980, 909, you know, whatever number you could think of that's bigger than 6, it would be included in this shaded region, in this shaded part. So the numbers that would work in this case, we can list 3 possible solutions. So we can say that R could be, again, our variable R could be 7, 8, 9, 10,000, right, 100,000. As long as it's bigger than 6, it's going to make this statement true. Because again, I can replace the R with all of these numbers and it makes it true, right? 7 is greater than or equal to 6, that's true. 8 is greater than or equal to 6. 9 is bigger than or equal to 6. 1,000 is bigger than or equal to 6. So all of these numbers could work. Right, I know they only asked me to list 3, but any number bigger than, that's why we do the number line. Any number bigger than it would work.